All right, so we'll begin here. Welcome again, everybody. My name is Ravi. I'm the moderator for today's session. I'll be moderating things related to the housekeeping items, the Q&A at the end, or in general, any webinar-related difficulties if you're facing at your end while joining. So just type a message and send it to me. Just a quick introduction about myself. So my name is Ravi Sahu, founder and CEO of Strayos. And in today's webinar, the goal is to really uncover some of the things related to understanding of what are the ways geometric reconciliation, geotechnical reconciliation, and design conformance plays an important role for your day-to-day mine planning, pit analysis, and then what the benefits it brings to the overall operations. We will introduce the topic very soon. What is Strayos is? Strayos is a software solution ranging from everything from surveying to drilling and blasting solutions. And then we have solutions covering geotechnical reconciliation. And then also on the mill side, we have solutions which can real-time monitor production fragmentation as well. So that's a quick introduction about Strayos. Since we have a lot of content today, I'm just going to go directly in introducing the topic here. So topic for today is using drones and AI for automated geometric reconciliation and pit analysis. And our speaker for today is Scott Muir. His introduction is he's a geotechnical engineer. Currently, he is a principal geotechnical engineer for Entech, an international mining consulting firm. He specializes in open pit and underground geotechnical projects, both in the area of consulting and operational support. He has a master's degree in mining geomechanics from the Western Australian School of Mines. His career to date as a geotechnical engineer has involved 14 years of extensive experience, both in open pit and underground mining operations in different countries, New Zealand, Australia, Africa, Mongolia. And his experience includes senior roles in technical services, supervising and mentoring other technical teams, project management, stability assessments and analysis, slope monitoring, hazard identification, and the design of ground reinforcement in both lateral and vertical development. So thank you, Scott, for our today's session. Yeah. With that, I'll just quickly talk about just the housekeeping items for everybody who has joined today. Please type your questions in the question box. We will moderate them at the end. If you have a specific questions throughout the session as you're listening to the presentation, please continue to do so that we will prioritize them in the last 10 minutes. For the recording of the webinar, yes, we will send them in about a week. If you are looking for some credit hours and you need a certification of this webinar, we also provide that. So you can email your request at hello@strayos.com. We will type that in the chat box. If you have any specific questions after the webinar that you would like us to address that you could not you couldn't question here, or we couldn't answer at the end of the webinar, we will type them and send it over a blog form as well. So with that said, we will kind of begin today's session. So Scott, take it away.
No worries. Thanks, Ravi. Thanks for the introduction. As Ravi mentioned, my name's Scott Muir. I'm one of the principal geotechnical engineers for Entech Mining Consultants. And today, as Ravi mentioned, we want to run through a bit of a presentation on wall reconciliations, but not only on open pit reconciliations. We'll also touch on open underground and vertical development reconciliations and the process of traditional methods versus the inclusion of AI in the reporting process. I'll just share my screen. Can you see that, Ravi, from your end?
Yes, all good to go. It's looking great at my end. Hopefully at the audience end as well, it looks good.
All right, no worries. Look, I guess just as a brief overview and agenda, what we want to cover today is a bit of a basic overview on what is a reconciliation and why we should complete reconciliations, just to make sure everyone's up to speed and we're all on the same page. A review of different styles of reconciliation. So we're not only looking at open pit, although the majority of this presentation will be centered around open pit reconciliations and mining, but also underground development reconciliations as well as vertical. Traditional versus AI methodology and how the inclusion of AI in the workflow can help us, and a general discussion around what is the way forward. So I guess, what is a reconciliation? In general terms, pit recon or any type of excavation reconciliation is a measure of how the as-built excavation has conformed to the design. So it's an overview or a review of whether the design and operational practices are appropriate for the in-situ ground and environmental conditions. So basically, is what we're doing suitable for the ground and processes that we have in place? Why do we complete reconciliations? So why do we bother with all this work that goes into completing excavation recons? In a generalized form, reconciliations determine if our current practice is acceptable. So from a design perspective, are our design parameters correct? And operationally, do we have the right systems and processes in place to help us achieve that design? It's a measure to determine if site is achieving the required metrics. For open pit, we're looking at obviously crest loss, toe flare, catch capacity, bench face angle. For underground and vertical development, we're looking at our overall achieved profile, but we're also looking at quality conformance, reviews of the installed ground support. So are we looking at the correct ground support installed on the correct spacing in the correct place? Highlighting these areas of non-conformance also allows us to review the implications that this has on an operation. We can then identify and resolve the root cause and obviously fix what's going wrong and improve what we're doing going forward. So we can quantify the impact of a system, process, or change. I guess a good example of this would be drill and blast, for example. We all know that drill and blast can and does have a significant impact on our final wall profile. And we can quantify the impact of an environmental change. So are we seeing a fully depressurized high wall, or do we have a fault zone running through our eastern wall that's resulting in higher than usual overbreak for this style of mining? The available catch capacity that we have and the historical wall performance will go a long way in determining our future wall design. If we don't know what we have in situ, it makes it very difficult to justify any design changes moving forward. Overbreak in our wall, our bench face angle, so these metrics can also be linked to tarps that we've got set up in operations, and these will allow us, the operation, to have systems in place to reduce any risk that we have when we're having trouble achieving the final design. So if we're not achieving our full catch capacity, or we're seeing steeper than design walls, obviously this tarp will then go on to dictate predetermined standoff zones or corrective actions, a review of the design processes. So why do we bother with recons? Oh, hold on, Ravi, I've just lost you.
I can still hear you.
Okay, good. You can still see my screen?
Yep.
Okay,
It's
yeah,
gotten shrink. So if you want to like expand it, maybe make it as a full slide, that would be good. Yeah.
No worries. All right.
Perfect.
So why do we bother with Recon? So I guess when reviewing an open pit operation in particular, poor wall conformance can and does have significant implications. So are we looking at a required step out of the wall, which in turn will sterilize ore tons? And in a lot of situations, these ore tons are non-recoverable. Does it result in additional haulage? So obviously this has schedule impacts as well as costing impacts if we're removing additional waste in comparison to ore that we weren't originally designed to do so. And any non-compliant catch capacity results in an increased risk profile to workforce and machinery on the operational floor. So if we have a specifically designed catch capacity and we're only achieving 70% of that catch capacity over the strike of the wall, obviously that reduces what we can catch and increases any standoff distances that are required at the toe of that high wall. I guess we're fortunate these days to have the ability to capture in detail what we have on the ground. With the advent of a lot of drone reconciliations or drone imagery. And this benefits site from a technical and operational perspective in the form of increased safety, decreased costs, and minimal disruption to our schedule. However, unless there's an accurate and rapid method to recognize these areas of non-conformance and taking that and implementing improvements, a large percent of these benefits will go unrealized. And I guess the key here is both accuracy and speed. If the results are not captured and turned around quick enough, the required changes can't be made, or by the time the changes are ready to be made, we've already moved on from an operational perspective. And look, I guess in a very generalized statement, and this definitely doesn't apply to all operations, but a lot of sites we see are time poor, and from a manning sense, resource poor. A lot of the departments are maxed out with the work that they're already doing. They're not set up to take on new responsibilities, at least not without neglecting another role or another area. And a large percent of site engineers are already consumed with full daily workflows, continuing to maintain manual reconciliation process, and report simply doesn't happen on a lot of sites you go to. I believe everyone understands that the process needs to happen, but it comes down to a matter of resourcing. As we've touched on, I guess the majority of existing recons and reporting methods can be both labour and time intensive. It involves the manual ID and digitisation of tows, sectioning of ore, and the generating of reports. So currently, where do we sit? I guess the majority of mines nowadays, fortunately, do collect a high level of data. Unfortunately, only a small percent of this data seems to get used to its full capacity. And one of the reasons for that is actually taking that raw data and transforming it into something usable it becomes quite a time-consuming process, and sites and mining operations often don't have the available manpower to dedicate to doing that. However, when we do use this data correctly, the data will provide value-adding input into decisions and workflow based on mine sites. So I guess the question out of all of this is, how do we get the most out of the data, and how can this inform business decisions moving forward?
Scott, just one quick logistics item. We can't see your video. I think we lost your video. If you can check.
All right. No worries, Ravi.
Perfect. And it seems like there is a time for the poll number 1. So I am going to be releasing the poll 1 if everybody can participate. Yeah, so the poll is, what is your current method of geometric reconciliation and pit analysis? You will see in your screen. We'll leave the poll open for next 30 seconds or so. Great, very interesting answers here. We'll leave for last 15 seconds here. Still see some responses coming in. Great, so it's time to close the poll. Interesting responses here. So majority of the focus is the CAD-based softwares. That's where a lot of the reconciliation is happening at the moment, and leaning towards also on the semi-automated softwares as well. Thank you, everybody, for participating in the poll. Great.
All right, thanks, Ravi. Now, as I mentioned, the primary focus of this presentation will be based around open pit reconciliations. But I didn't want to ignore underground or vertical development compliance to design, as I think, you know, what we do in either operation, we can learn from each other here. So there's a lot to be said for that. So this is a conventionally sunk shaft, drill and blast methodology, and I think the diameter was 7 meters for this. Once the floor was marked, or once the bench was marked and the ground support installed, the as-built profile was scanned, and what we've measured here is volumetric overbreak as a percentage. So you can see for this section of the shaft, that 7 meter diameter shaft, our volumetric overbreak was 12.36%. And as we scanned after the ground support had been installed, it then allowed us to perform quality control on the installed ground support. So we looked at bolt spacing, ring spacing, and the height of the lowest bolt off the bench floor. We compared that to our acceptance criteria and whether it was a pass or a fail, and obviously any actions which needed to be taken to bring our design back within our criteria was taken afterwards. So we'd measure the average bolt spacing, average ring, and lowest bolt, those average metrics, and compare that to what we deemed acceptable. You can see here the image from the scanner. So this has gone through and completed a calculation on every bolt spacing and then also every ring spacing. That allowed us to continue very accurate quality control on the ground support that was installed. And over to the left-hand side of the screen, you can see an image showing the as-built shaft in comparison to the design barrel. So you can see the green and the blue indicating various levels of overbreak, and the red is obviously sitting proud of the barrel design and indicating tights within the shaft itself. So I guess one of the important things to consider here is that not only is the actual data collection and the data processing important, but the way in which we convey this information through to operations, tech services, and management is also equally as important. We can collect all the data that we want, but unless we can effectively convey that information, it's not going to get us very far, and it's not going to help us convey the message we want to get across there. I'll just change tabs here, so you should be able to see a change. Now, part of what we included in our presentations or our reports was a 3D image of the actual shaft profile in comparison to the design. And again, this goes a long way in the actual end user being able to view the data, being able to see that reconciliation in comparison to the design and seeing where we get our overbreak, where we get our tights. As most of you know, with shafts, tights can be more problematic than overbreak a lot of the times, especially if we're wanting to lower steel cans down afterwards. So this was quite well received, and the fact that people could actually get their head around when we say, right, we have 12.5% volumetric overbreak, what does that physically look like? You know, people can begin to gauge and see in their minds what overbreak looks like. Obviously, when we're looking at long-term trends here, we'd overlay this with various lithology or structural intersections. So if we're beginning to see large areas of overbreak, can we also tie this into a change in lithology, a large-scale fault or shear zone coming through, or have has there been a change to the drill and blast practices? Is that why we're suddenly seeing tights on the northeast wall? Stepping back to the original presentation. But the same style of data collection and report processing for underground design compliance. So obviously once we've bogged the heading and scaled, we would go down and complete a scan of that face. Now, I guess one important thing to note here is that not only do we scan the heading as it is, but that scan also picks up the previous heading. So this, we pick up the exposed face, and then we pick up the ground support that's been installed, so the mesh bolts and fibercrete behind us. And that then allows us to complete quality conformance, again, like we did with the shafts, but in underground lateral development. So here we're saying we've got 18.5% overbreak, so that's volumetric percentage. This allows us to go back and calculate the spacing on bolts and the ring spacing. So again, assessing these metrics against site-specific acceptance criteria and say, right, is our bolt installation to specifications, or do we need to remedy and issue a rehab plan? Looking at this, the image on the left-hand side is the fibercrete layer. So obviously, like I said, we picked up the bare heading, and then once we've applied the fibercrete and we scan behind us, that then picks up the the installed fibercrete. Yellow is underspray, blue is overspray, and green is on design, plus or minus our acceptance, which is very handy. Obviously, if we're looking at our fibercrete installation, it's a significant cost. It's also a significant time to spray and then wait for it to cure. So if we can look at a heading and say, right, for the last 3 cuts, we've oversprayed the right-hand shoulder by 50 mil, why is that? That could equate to 3 cubes, 4 cubes worth of spray going up that we don't have to install. Or conversely, look, we're underspraying the floors. We need to get back in, put up another spray to bring everything onto design. And our right-hand image here, again, as we were looking at previously, is a pure as-built versus design. So we're looking at the as-built development versus a design profile. And as part of that reporting process, also issuing, like we did before, a 3D image so that the viewers can sit there and say, right, the geotechs have sat down and said we have 20% overbreak in our left-hand shoulder. What does that physically look like? And just bringing people on board and bringing people along for that journey, I suppose, goes a long way to getting the changes needed, or getting the changes implemented that you need. I guess a bit of background to this chart. So in order to get this set of data here, so this is overbreak percentage over time for lateral development. So a laser scan was completed on every heading over about, I think for this was approximately 6.5 kilometers of development over the space of a bit over 12 months. There was a dedicated data processing team which would take the scan data and calculate the overbreak and the ground support QC. They would then issue the reports as we just discussed, and then on a daily basis we would sit down with drill and blast, engineers, tech services, operations, and the geotechs and discuss the results. And obviously any issues that we highlighted, any areas of overbreak or underbreak or any developing trends, we would investigate and actions were put in place to correct any outstanding issues. And as you can see here, that continual focus and communication and working with the rest of tech services and operations to focus on what we need to bring our overbreak under control pays dividends. So we started here with about 15% overbreak, and then with that continued focus, that level of overbreak would drop down to around 9% for the majority of the 12-month period. You can see it kicked up a bit at the back end around February 2018, but all up, that was a very good result. I guess as a run through, that covered vertical developments and underground developments, and I guess, various reconciliation methods that I've employed in the past. And now looking back at open pit and the more traditional methodology that's been used to complete the open pit reconciliations, I guess one of the things you first notice here is the quality of the actual open pit scan or the pickup itself. So not the greatest quality. You can see large spacing in between individual points on the pit shell. And also, I know on this example that a lot of toes were picked up and just projected up to form the crests. So you can also ask what was the point in doing a reconciliation to start with, and it's a valid point. But the process I went through at the time, and you can see we went through and manually sectioned. In this instance, in this case, the wall, we had 58 sections, and I reviewed 29 of them. So I went through and reviewed half of them based at 10-meter intervals. So even the intervals that I did examine obviously are quite well spaced or spaced far apart, not the close proximity of data that we would really require or that we would like to see. And what did that tell me? It told me that 40% of my area of interest had greater than 7 meters catch capacity on the bench. So a lot of work and a lot of time went into that, a lot of sections, a lot of manual work. And the data I got out was good, it was fine, but it was fairly limited in what I could get from it. The whole amount of effort that went into it wasn't very rewarding as far as the data that I got out of it at the end of the process. Still looking at the open pit recons from a traditional sense, again, the same style of data that's captured. We're just looking at crest loss here, and the amount of crest loss is broken down into half-meter intervals, good, moderate, poor, and very poor. So again, it's good data, and it does tell us information on a very specific data set, but it is determined on, or the accuracy of this is determined on the quality of the pit pickup, which in my previous example was very poor, and on how closely spaced I've cut my sections. So if I'm cutting them at 10-meter intervals, we're not really getting that proximity of data that we'd want to see. Ravi?
It's a time for poll 2. So I'll just release that. Yeah, the poll 2 focuses on how often are you doing geotechnical reconciliation and design conformance analysis. We'll take 30 to 45 seconds and leave this poll open. Okay, last 10 seconds and we'll close the poll. Well, thank you everybody for participating. It seems like the frequency is still at a monthly or more longer term durations of this analysis happening. So thank you again for participating. Over to you, Scott.
Thanks, Ravi. So what is the way forward when we're looking at reconciliations in a traditional sense versus the incorporation of AI to assist us with our workflow? Look, I personally believe there is a massive benefit in using AI to improve and streamline our workflow. We currently have access to high-resolution drone data, which has previously not been widely available, and this allows a very accurate review of the as-built pit and ensures the results that we're using for any analysis are reflective of the in-situ ground conditions. Based on the accuracy and the speed of report generation that we can now do with the incorporation of AI, post-excavation surveys, measurement, and reporting should all be considered a standard part of the wall sign-off process. There is really no reason now, with the inclusion of AI and drone imagery, why it would take a full day of manual calculations and spreadsheets to complete a reconciliation on a pit wall. The beauty of this, and it's something that I consider key, is that in order to make this happen, site does not need to collect any additional data outside of what they're already doing. So the majority of sites that I work with these days are using drones on a regular basis and taking the data that they've collected from that drone, uploading it into the program, and then having that processed. There's nothing else that they need to collect that would add into their daily workflow. And obviously with sites already busy, every engineer or surveyor is running around already at max capacity. Any additional requests, anything that's not critical to daily operations, will often get pushed to the back of the queue. But if we can take that data that's already captured without any additional work being done, I believe that's key to making sure that these recons can happen on a regular basis and that we get the full use of data that we're collecting. I'll just stop sharing for a second, everyone, and then reopen. Give me 2 secs. Right, so I guess we've discussed the influence of AI and how that can assist in our reconciliation process. And I guess in this example, if we're looking at open pit recons in particular or compliance to design, the work that Ravi and the team at Strayos have done is very impressive in my personal opinion. What I've done here is taken data from drone scans, uploaded that into Strayos, and that's been automatically processed. I'll step you through the actual software and its abilities and what we can do in this right now. If you've got any questions, obviously, like we've said, type them at the bottom of the screen and we will get back to you with answers as soon as we can. Right, so this was a drone picked up in site picked up in Western Australia. That image has been processed and the AI generation has gone through and picked up the crest and the toes. So obviously we've got the crest is bringing on as orange and the toes is yellow. I'll zoom out a bit so you can obviously see the full impact of the pit. And I've since then gone, just as a time saver, and created 2 areas of interest. So if you can obviously complete any reconciliations on the pit as a whole, or if there's areas in particular that you want to focus on, by simply coming along, adding a polygon, you can create any of the geometries. I've created geometry B and geometry A here, which will then allow us to focus our recons on these 2 areas. So if we want to look at high wall height, I guess actually once the imagery has been uploaded and processed and the AI has gone through and recognized the crest and the toes, it's critically important to also go through with a set of eyes and validate what it's picked up. Every bit of analysis that's done from this point forward will be based on the current pickup of the crest and the toes. So you always want to go through and make sure that what it is identifying as crest and toes are actually accurate. What we can do here is bring in the projected high wall height. So depending on what our pit metrics are, and obviously the slider over to the left, depending on what we want to look at, what our wall design height is, we can change what we're viewing in the screen to highlight areas of concern. Obviously, if anything over, in this example, say anything over 20 meters is of concern to you, and over the actual design height of the wall, you can highlight that as an easy way to visualize what's in compliance and what's out of compliance. We'll now look at bench face angle. So again, toggle on bench face angle. And this is here, anything under 57 degrees or anything fatter than 57 degrees is highlighted green, and yellow sits between 57 and 63. Again, if I want to change that, I can do so very easily just by sliding the toggle on the left-hand side to identify any areas of concern. If we then want to look at catch berm width, so we've looked at our batter height, bench face angle, and now we're looking at the width that we've actually achieved on our catch berms. Again, toggling through, if we're concerned, right, anything under 5 meters should be highlighted red, that's what you've got there. So depending on what our site requirements are and what our individual wall designs are, it's an easy way to visualize what we've got. When you compare that back to the manual reconciliation open pit process that we looked at previously, I did this in a fraction of the time as what it took me to do the manual work. Now, the beauty of this, obviously, the processing is one part of reconciliation, and obviously setting up the metrics that we want to review. But then also report generation, so we can then distribute that report to site, plays a massive part. So down here, if I click High Wall Report, that will then auto-populate a report showing the key characteristics and the key statistics based on what we have. So this is the automatically generated report style coming out of Strayos Geotechnical. It gives us a 2D and 3D image for all of our metrics. So for example, this is high wall height. And
Hi, Scott. I believe the report screen is not showing up. Maybe it's not shared, that one. Yeah. There you go. Yeah, that's perfect now.
All right, thanks, mate. So obviously we can edit and customize what we want to be in this final report. So we can change our orientation of our 2D view and what we want to see in 3D. So this is high wall here. And if we step through to bench face angle, obviously again in 2D, we can orientate this to whatever we want to focus on. If we want to zoom right in. And then our bench face angle again, we can zoom in for presentation purposes. Same with catch bench width in 2D and 3D. Now this then comes to a summary report and obviously breaks down our 3 key metrics that we've measured here: high wall height, batter bench face angle, and catch bench width, and gives us our statistical breakdown on our 3 metrics. So if we're looking at bench face angle, inside our geometry A, so inside our first box that we created, our area of interest, 25.5% of our walls sit between 57 and 63 degrees, and 74 or 75% of the walls sit less than 57 degrees. And obviously these metrics here are controlled by what we set up previously when we were playing around with the toggles on the processing page. We then go into a more detailed statistical review of each of the 3 metrics: high wall height, face angle, and bench width. So we've got a bit of a breakdown on our maximum, mean, standard deviations, 25th, 75th percentile, and again, our percentage that we've achieved for our different wall geometries. And obviously showing this in plan view. So that's high wall height. We step through into bench face angle, and then catch bench width as well. So basically all the metrics that we needed to know have been included and broken down in this reporting function. This obviously will then also carry on for our geometry B, or as many area of interest as we populate, to be honest. So that gave us a brief overview of our 3 primary metrics and what we've actually got in situ. Now, what we also want to do is complete a compliance to design check. So that didn't tell us how much crest we've lost, what our overall compliance to design is, or anything along those lines. What we can do here is upload a DXF of your pit shell, so of your design, and you can the intent is that we compare that design to the actual as-built and actually get proper crest loss, toe flare, compliance to design on our berms, and what our catchment capacity sits at. So I've already uploaded our design DXF. We can obviously turn that on.
Yeah, I think the other screen is not showing. There, yeah.
Thanks, Robbie. So we can turn that design DXF on and off. I'll leave it off just for visualization purposes. But now when we run crest loss or toe flare or berm compliance, it's actually measuring the difference between the design versus the open pit. So if we wanted to look at crest loss, for example,
It's probably in the 2D view, yeah.
It should be right now.
Yep.
So here we're actually measuring the crest loss. So anything, I'll just change that. Anything under 2.5 meters here, crest loss we can see is green. Anything from 2.5 to basically, change that to 5 meters, is obviously indicated in yellow. And anything above that is indicated in red, which is not in this instance. So previously we were looking at what we have in the ground, and now we're reviewing our compliance to design. The same can be said for toe flare. So if we want to see where that toe sits in comparison to the design, is our toe sitting proud? Is it behind the design? So we can obviously zoom in here and say, right, in this instance, everything is sitting proud of the design. There's nothing behind the design. And our overall berm compliance. So what we can see is, I'll bring up our metrics. So anything we've got in green here is, you can see down the bottom, 86.5% of our berms within geometry A are within plus or minus 1 of the actual design. So that's where it sits in compliance to design. We can bring so again, if we want to look at this in the histogram style views, we can bring out a catch bench width against our length of high wall, and again our batter face angle. So where our populations of batter face angles sit, we can change the bins. At the moment we're just looking at 1 degree. If we change it to 2 degree, we can see what that does to our histogram. And as before, when we produced a high wall report for our metrics, we can also produce a compliance report. So once we've got these reports and we've gone through and customized them to what we want to view, it's simple as downloading the PDF, and then we have that ready to use and discuss with management, operations, and the site team. Just reshare. Can you see the PDF, Ravi?
Not yet. It's pulling up now. Now I can see, yeah.
No problems.
Perfect.
So I guess in summary of all of this, most sites know anecdotally, but there's rarely much data and metrics around to support this, about how much overbreak or how much underbreak they're getting throughout the walls. So every site you go to speaks, yes, we're getting a lot of crest loss. We know we're getting more crest loss on our eastern wall than our north, but not a lot of sites can actually put hard data behind this to support a change in drill and blast processes or a change in wall orientation when we're intersecting a certain amount of structures. So to be able to take this data that we collect in the field, process it and produce the reviews that we need, in a fraction of the time compared to what we've historically done is a massive improvement. I guess the key outcomes is not only to improve safety and compliance to design, but feedback into that design loop where we can actually add true value to site. We can save money on sites and we can improve schedules. I think that's the final poll there, Ravi.
Yeah, we'll make it live, the poll. Number 3, it's what is your current method for data capture for design conformance analysis? So just curious about what tools that you are using for as-built data capture for your mines. So we'll leave it the last 10 seconds in the interest of time. Okay, we'll close the poll. Very interesting that seems like drone is ubiquitous in every site and everybody's using drones. So it's great. Thank you everybody for participating in the poll. That's it. So that was the last poll here. Scott, over to you. If you have any last concluding summary here before we kick off the Q&A.
Yeah, thanks, Ravi. No, look, that was about it. I cut myself short, sort of just been trying to be cognizant of time here. But yeah, thanks everyone. And if you've got any questions, obviously I'm just now looking, there's a few questions that people have typed in there and we'll launch into that. Thanks, Ravi.
Yeah, no, thank you, Scott, for the session. There's a lot of great, points were made about, both in terms of how reconciliation plays an important role and what are the traditional methods versus AI. So I think I hope everybody got a good overview from the sessions. And then also, I certainly learned a lot more on the different items, how reconciliation is a critical part of operations. I always have looked into the drill and blast as one of the items that plays critical role in this workflow, but almost like it's a vice versa. If you are doing a reconciliation well, your drill and blast operations can improve well as well. So without further ado, we have about 9 minutes here, so we will address as much as questions that has been flown in so far. So I'll start in order. The first question here, as I can see here, let's start with the maximum number of votes here. So the question is, I found the drone data from site can be hit or miss for reconciliation or slope audit work. Do you have a specific flight pattern or a software you recommend to clients? Do you usually get LiDAR or photogrammetric data? So I think I can answer this question, Scott, and feel free to add. The drone data, certainly, I think it's all about like how the data has been captured and what's the end goal here. If it's related to really slope audit work, we want to make sure that we have a right flight planning operations done, right flight pattern done, because the integrity of the drone model that gets generated very much relies on what results and output you're going to produce. And that all goes back to how the flight was planned, which is the ground sample distance information, the overlap, as well as the accuracy, which means whether you are collecting with RTK or putting ground control points so that your the XYZ accuracy is very intact. So all those goes into play. From the flight planning recommendations, there are several good flight planning apps out there. We can recommend some of those. There are, if the slope is at a varying altitude, there are various terrain changes in terms of the heights are there, so it can counter those as well, the altitude changes. So we'll be happy to kind of send a separate note on different flight planning apps which have worked out well in my experience. Scott, would you like to add anything on the data accuracy and integrity side?
No, I think you summed it up fairly well, to be honest, Ravi.
Okay, perfect. The another question with the highest number of votes here is, I'll read it. For the bolt pattern compliance, did they have to be manually identified in the scan, or was something installed on them so the software could automatically identify them?
All right, no worries. So that's, I guess, the same answer will apply both to underground as well as vertical development in those two examples that we looked at. To start with, after the scan data had been processed, it was a manual process in the early stages. So we had data analysis would sit down and actually manually measure in between individual bolts, obviously harking back to our manual processes and how long that took. Over time, that developed, the blokes and the people that were looking after it developed machine learning capabilities to it, and the software would automatically recognize the bolts and automatically measure the distance in between the bolts and the ring spacing as well. So the amount of time that saved was significant. And just looking at your question now, no, there was nothing installed on the bolts. It was just the machine learning could pick up the bolts themselves.
Thank you, Scott. The another question that we have is, are you able to import new images, drone data in the program while maintaining the same parameters and analysis for statistics? Seems like I may need to clarify the question, but what I understand from this question is importing the new images on the same drone model it can be done, but it almost requires a reprocessing to generate a new accurate 3D model where you can run the statistical analysis. So it's always better to reprocess if you are adding more data sets or more photos on the existing areas. The next question here is, do you use pit design to help the AI to detect crest, or is all autonomous? It seems like I can answer this question as well.
Yep.
At this moment, the AI detects everything on the as-built information, which means what the data that's been captured from the scans. It can be done from the design as well, but the goal is to actually find out issues and concerns on your as-built data. So if the things are changing as built, the AI kind of more useful on every survey, the detection that has been carried out. And it's fully autonomous, which means you push the data and you're getting those detected results here. Although the user does have a control to manually edit them in an easy way. So we have time for last two questions. So I'll come back here. Do you foresee this work being applied in the future with the high resolution satellite data? Scott, what do you think of that? Like, with the satellite data would be good enough to analyze? Yeah.
Sorry, Ravi. No, personally, not at this stage. I don't think you're going to get the same accuracy that you can get with the drone image from satellite data. Not yet, anyway. And obviously, being able to get down and inside the pit with the drones themselves, you're not purely looking from in plan view. You're able to get down inside the pit and get images orthogonal to the actual pit walls itself. So the data collection process is far more detailed.
Yep. Perfect. Another question here is, Recon looks great. Are you able to map structures and geology from the drone images? And that was a question, and there is a comment there. Ideally, you want to have one tool to identify everything in one place. So yes, I think the structure and kinematic analysis can also be done in the same tools using the drone images. Today's focus was more on the design conformance, so we covered that as a topic. We have some time for one last question since there are several of them here. One last question that I have here is more related to what about scanning speed and the post-processing of raw data? Would you be willing to share some numbers? Yeah, so that's a good question. The scanning of pit, that all depends upon how big the pit area is and the pit analysis. So which brings the question of how much, what's the flight operations looks like, what's the overlap. So if you have 1,000 photos that's been captured through drone images, or if you're using a LiDAR data, how big that data size is, that all depends upon the processing time. And we can share some numbers, definitely, what's the processing time looks like there, and also the flight planning side as well. So yeah, we're on the top of the hour here. I want to thank Scott. Thank you for such an amazing session today. There's a lot of information from understanding the design confirmation and what's the process looks like from an engineering perspective. And then what are the different KPIs that we should be tracking here. So thank you, Scott, once again for conducting this session.
And thanks for having me, Ravi. It was good.
Amazing. And I was very impressed kind of how you quickly went through the software and demonstrated as well. So I wasn't expecting that. So thank you again, everybody. And to the audience here, please give us a feedback. How did you like the session? And what other topics you are interested in listening from us? Do share your feedback, your thoughts. And again, thank you very much for your hour-long time here. We very much appreciate. I know you're joining in from different time zones. You could be doing many other different things, but appreciate your time here. And until the next one, goodbye.
Everybody. Thanks, everyone. Talk to you later.
Thank you.
Cheers, Ravi.